Saxon Advanced Mathematics, Lesson 50. We're going to talk about trig equations today, you guys. And this is going to use that big body of trig knowledge that we have wedged into our brains at this point. And we're going to pull that together and use it to solve some slightly different kinds of problems. I think they'll feel familiar and kind of fun to you. All right, let's just dive in, and I'll remind you of pieces of information as we go. Our problem says solve sine of theta equals 1 over the square root of 2 given that theta is between 0 and 360 degrees. Okay, so what this problem is asking us to do is list the angle measurements of angles that will give us a sine of 1 over the square root of 2, but we only have to go through the first spin around the quadrants. We don't have to keep naming them, and I'll show you exactly what I mean by that when we start to nail it down. So the first thing we need to do is we need to recognize, okay, this is sine, so this is Oscar had, right? Let's just write down sine, cosine, tangent. Let's just write down the basics, right? Oscar had a hold over Arthur. This is sine, so this must be that. Now, we're thinking, which of our triangles would yield to us an opposite sine of 1, an opposite side of 1, and a hypotenuse of square root of 2? Oh, well, that's our cute little baby, right? So let me just draw out all 4 quadrants. It's positive, so let's start with the first quadrant. We know that if it's 45-degree angle, then that will give us 1 square root of 2, right? We've got that memorized. So hypotenuse would be, or opposite would be 1, hypotenuse would be square root of 2. Okay, that works. So that means a 45-degree angle is one of our answers, right? But we know that each sine is positive and negative in 2 quadrants apiece. So let's look at that chart. I've got it here handy. Remember, it's sine, cosine, tangent, sine, cosine, tangent, sine, cosine, tangent, blah, blah, blah. So we're looking at sine. We want positive. It's also positive in the second quadrant. So that would look like this, right? And here would be another 45 degrees. And this would be 1 square root of 2. So this angle would also yield opposite over hypotenuse of 1 over square root of 2. So the question is, what's the name of this angle? We count from here. We take 45, we take 90, and then we take another 45. So that would be a 135-degree angle, okay? We don't want the angles down here because they're negatives, right? Sine is negative in the third and fourth quadrants, so we don't want those because we want positive. And by limiting it this way, we don't have to worry about, okay, well, if it's 45, then we have to add 360, so that would be 405, and then add another 360, and it would be 765. We don't have to keep doing that because John says, just spin once, just go around one time and tell me which angles would give you that sign. So this is our final answer. Yay. Beautiful? Yes. Okay, there are 3 total examples in this lesson. So let's carry on. Example 50.2. Solve two plus square root of 3 secant of theta equals 0, given, whenever we see this, we're relieved. That means we only have to worry about 1 spin around the dial. That is a simplification. This just makes us happy when we see it. All right. This is a little unnerving because, I mean, we can kind of deal with secant. We can remember what that is. But what the heck is all of this business? How are we going to deal with that? The trick is in using some algebra to start. So what we want to do is we want to isolate the function. So we're going to subtract 2 from both sides, basic algebra. Square root of 3 times the secant of theta equals minus 2. Okay, divide it by the square root of 3. Yes, we can do this. So now we see that the secant of theta, some angle that we don't know, is going to be equal to minus 2 over the square root of 3. Oh, okay, we're getting warmer, right? We're getting warmer. I'm going to find the right page in my little book. For what? I don't like those notes. Never mind. Okay, we have to remember what secant is, right? We've got sine, cosine, tangent, and then what are the reciprocal functions, right? It's cosecant and secant and cotangent. So secant is related to cosine. So if this is that, then this is that, right? It's the reciprocal function. It's upside down from it. Okay, so we can figure that out. So that means that this would be the hypotenuse over the adjacent. Does that make sense? And it's minus. Okay, that's good. So now what we're looking for is what angle, or what triangle rather. Well, I can see by these numbers that it must be a 30, 60, 90. So let me draw all four. We want negative. Secant is buddies with cosine. Cosine is negative in these two quadrants, the second and the third. So that means we're going to use these. We're not going to use those. Let's just take a look at how this triangle is oriented so we draw it properly. This is the 30-degree angle. This is the 60. This is the 1 and the 2 and the square root of 3. We want the square root of 3 to be the adjacent side. Okay, so this is how we want it, right? Because if we're standing here, this is adjacent. If we're up here, it's the opposite. Okay, so we want it to look like this, because this is where the 30 degrees will be. Then this is square root of 3 and the 1 and the 2. Okay, so this angle, as we've drawn it, does it give us a secant of minus 2 over the square root of 3? The hypotenuse is 2. The adjacent is square root of 3, and it's negative because cosine in the second quadrant is negative. So this angle, which is 30 less than 180, theta equals what? 150 degrees. Beautiful. That's one triangle that will give us a secant of minus 2 over the square root of 3. Beautiful. Where's the other one? It's in the third quadrant. And that's going to be like this, right? Because there's the square root of 3, and here's the 2 now up here, and the 1. Secant, which is the hypotenuse of minus 2 over square root of 3. That's the adjacent. This is 30 degrees, rather, 30%. And so this is 180 to go all the way to here is 180 plus another 30. So this is 210 degrees. And that's the right answer, you guys. And again, this is our friend. It says you only have to consider the first 4 quadrants. You don't have to keep spinning around and adding 360 to all your answers, because we would have to go on to infinity, adding 360 to both of these to get all those new coterminal angles. We don't want to do that. Did I smiley face this one? Yeah, we got that one right. Okay, so that's this one. So what we learned in this one is that sometimes there are crazy numbers mixed in on this side, and we have to do algebra to clean them up. And we're going to do that again right now for our last example from this lesson. Solve. Remember that I want you to copy everything as I'm writing it. Pause me as needed. Okay, there's our limiting, so we don't get dizzy running around in circles for the rest of our lives. All right, we see a nice function in there, but it's buried with these numbers, so let's get rid of that. Let's subtract 3 square root of 2. It's looking scary right now, isn't it? But that's okay. We're going to trust algebra to be our friend. 3 times the cosecant of theta equals minus 3 square root of 2. And then we'll divide both sides by 3. Oh, that looks so much better, right? Because look, that cancels and that cancels. So it's cosecant of some angle equals minus square root of 2 over 1. Cosecant is buddies with sine, right? The C's and the S's don't match. With sine and cosine, their reciprocal angle has the opposite letter. So if sine is Oscar had, then cosecant is ho, right? So that's good. So what's an angle? That would give us the 1 and the 2. Okay, we know it's 45. I'm getting ready to draw my triangles. So I know I'm not in 30, 60, 90. I know this is my hypotenuse, the square root of 2. We want it to be negative. So let's figure out which quadrant sine is negative in, because we know cosecant will be negative in the same signs. Sine is negative in the 3rd and the 4th, right? So we're going down here, and we want the 45 degrees, so I'm going to draw those in. I'll draw them both at the same time. Okay. This is 45, this is 45, and it goes 1, 1 square root of 2, right? 1, 1 square root of 2. So let's just double check. The cosecant should be hypotenuse of of square root of 2 over an opposite side of 1. Yeah, we've got that. It needs to be minus. Sine is minus in 3rd and 4th quadrant. Okay, this should be right. So now all we have to do is figure out what angles these are. So theta, remember theta is the variable that represents an unknown angle. Okay, so we have 180 to get us this far, plus another 45, that's 225 degrees. And then this one, I'm going to think of this one as 360 minus 45. So that would be 315. And that's the right answer. Don't you think those are kind of fun? They're kind of fun. Thank goodness for this. But they're kind of cute. It's kind of fun how we can do the little algebra to straighten them out. That's the end of lesson 50. I'm proud of you. Your brains are back online. And we are ready to tackle this week of homework. I know it's rough getting back up online, but you can do it. You guys did a great job on your midterms, and I have great faith in you. So I wish you good luck on lesson 50, your homework. I'm just looking. Yeah, the problem, remember from lesson 49, I told you that you did not have to do like the developments, show why in the log problems. Let me just show you so you know what I'm talking about. I told you that you did not have to develop the log laws, and the problem that requires you to do that in this lesson is number 12. Do the evens, or I'm sorry, do the odds. Always do the odds. In the past, I've said, oh, you can do evens or odds. It's fine, whatever you want. I'm not saying that anymore. Always do the odds. So you won't run into trouble with that guy. All right? Thank you. I will see you for lesson 51 next time.